favorite friends. This is Miss Berger.
And Mr. Lamb, and we're here today to talk to you about the next step in probability, which is?
Experimental versus theoretical probability. And those are super fun words.
Those are big fun words.
All right, your learning target today, I can identify and calculate experimental and theoretical probability. So let's talk about it, Mr. Lamb.
Okay, so the first thing we're going to do is get on the right slide.
Boom.
Oh, there we are. We're there. So what is the difference between theoretical probability and experimental probability? Well, if you think about those two words,
right,
they kind of explain themselves.
Yeah.
Theoretical is the theory behind it.
Like what should happen.
Exactly. Ooh, I love the word should happen.
Right. So this is what should happen when you're doing probability. Right? What should happen in theory.
Yeah, and we'll use that example that's the easiest one to use. You take a die, you roll it. I want to get a 6. I have 1 and 6. So if I do it 6 times, I'm guaranteed to get a 1.
Right. So in theory, Mr. Lamb should roll a 6, 1 out of every 6 times.
But we all know, if you've ever played any games that have a die,
sometimes it doesn't happen.
And sometimes like 6 comes up maybe 3 times in a row.
Yeah. So that would be experimental probability.
It's what actually
happens. Does happen when you do the experiment. So what should happen is theory. What does happen is the actual experiment that you're going to do.
Okay, and there's the big difference.
Yeah.
Should versus does.
Now we write them both still as fractions, and we can convert them to percents. So nothing changes in that sense. It's just understanding this is what should happen, this is what does happen.
Yep.
So let's look at one.
Okay, so I'm gonna take this. Now most times when we're talking as pre-algebra students or as advanced students, we're talking about compound probability.
Yeah.
Two things happening. So this is an example of what we call a sample space, because you can't know the theoretical what's going to happen if you don't know what the theory is behind it. So this shows you right here a table of rolling 2 dice, right? 2 dice. Two dice.
2 dice.
A pair of dice.
Yeah, 1 die. 1 die, 2 dice.
Yeah, be careful Googling die.
Yeah, don't.
Okay, so this shows you that there's only one chance out of, if you count these, there are 36 of them. There's only one chance out of 36 that you're going to roll a 1 and a 1.
Right.
There's only one chance out of 36 that you're going to roll a 6 and a 6. So this would be, theoretically, 1 out of 36. This would be 1 out of 36. And sometimes you wonder, like, what's the most common number that comes up when you roll 2 dice? Well, this shows you that the number 7 can happen 6 out of 36 times, or 1 out of 6 times.
Right, the lucky number 7.
But without knowing your sample space, you have no idea of what the theory is going to be. So sample spaces are kind of a big deal when you talk about it.
Right, so sample spaces are like the total outcomes, right? However many things, right? So if we wanted to know, it's kind of like simple probability, if we like circle back to our like original, our start point. So the probability of 10
with 2 die
would be 1, 2, 3
so
times.
3 out of 36.
Out of 36.
Or we could divide both of those by 3.
I could simplify that.
And make that 1 out of
1 out
12.
of 12.
Okay? So this just shows you like what the theoretical probability is of it happening. Now, how would you figure out the experimental way?
Well, to figure out experimentals, we actually have to do it.
Oh, you'd actually have to take 2
dice
and roll them 36 times.
Yeah.
If you wanted to have exactly the same numbers.
That's true, that's true. So yeah, and then the more we roll them, the closer we'll get to the theory and the theoretical probability.
I don't think we need to do all of them. I think they have the idea now of what we're talking about.
Oh, so what is the most likely, sorry. We got direction from our director back there. So what is the most likely number to come up? Well, that's 7.
Yeah.
I think Mr. Lamb said it, but we didn't officially answer.
Yes, you got to write it down. Otherwise, it didn't happen.
Doesn't count unless you write it down. All right, so now we're actually going to look at a cool website. So we're going to exit out of here that shows us, there we go, that shows us experimental and theoretical based on percentages. So we have this spinner, and it has 5 different colors. So in theory, we should land on a color, you know, like this, like pretty blue, this cyan.
Oh,
cyan.
I love cyan.
Cyan? Is that how you say it? I don't know. Cyan. Right? 1 out of 5
sounds like
times.
something from like Battlestar Galactica.
Right? I know. So if we actually spin the spinner, dun, 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 oh my god.
Oh my god. Right now, it's 100. She's magical.
I win!
Oh, buy me a lottery ticket today.
Right, I will, right? I'm going after class to buy some tickets. I picked the winner. So if you look here, because we've only spun one time, it says the chance of landing on the experimental probability of landing on cyan is 100%.
So if
But
somebody
that's
didn't
not
understand
realistic.
probability, they might walk away saying, you know, if you spin this spinner, it always lands on that blue card.
Yeah, but that's not true, right? Because if we spin again, hopefully it's not true, right? But now it lands on blue.
And notice that our 100, now because we've done it twice,
Becomes 50-50. And then the more we spin, the closer we'll get to the experimental probability. So sometimes when you're...
now notice,
Yeah.
we didn't do it. I'm really glad that landed on red, because I didn't want you guys to get the impression that, oh, every time they spin it's just going to land on a different color.
No, sometimes
Yeah,
it
so-
doubles down.
And so it, and I interrupted Miss Berger, and I apologize, because she was trying to say
It was.
that the more you spin it, you should start getting closer to these numbers. Not necessarily perfectly.
Right.
Why don't you spin it a couple more times?
Yeah, right, because right now it says yellow 0%, but we know that yellow really has a 1 out of 5 chance. So we're just going to keep kind of spinning. Oops. Ah! Maybe.
There we go.
Kind of keep spinning, keep spinning, keep spinning, and the more we spin,
The closer
The
some of these numbers are going to
closer
get.
we
Look, it
get.
hasn't hit yellow yet.
I know, poor yellow.
Yellow gets no respect.
No, neither did purple, and those are Larkspur colors. Oh, purple finally got in there, right? So, you know, the more
Yep.
we do it, the closer we'll get to these numbers, and eventually,
You know
if you do it enough, they'll all kind of even out to that 20% theoretical. Poor yellow.
Yeah, red they likes red.
Oh man. I really just wanted
You're
to
gonna go until it hits yellow.
I
aren't
really
you?
wanted to just hit it one time. Yay!
Yay!
Okay, so we did it, right? So, but if we look, we spun the spinner 20 times, right? So, right, remember, so 20 times, oops. So, so cyan, our original color, we started at 100%, really it balanced out at that 20%.
You keep touching the
I
board.
know, I'm sorry. It's been so
Probably
long.
the easiest way to see that is flipping a coin, which we know is 50-50, kind of heads and tails. And, sometimes like you'll flip a coin 10 times and you get 7 and 3. But then the more and more and more you do it, you're going to find that it's going to come out much closer.
Yeah.
The number of trials that you use,
true.
as our director just pointed
Yeah,
out,
trials.
you got to use the proper
All those
vocabulary.
fancy words, right? So we could calculate right now the difference between our experimental and theoretical probabilities by just really subtracting them, right? So if you ever get one of those questions, it could be like, Miss Berger spun a spinner 20 times. Here are the results of her trials. What is the difference between, blue's experimental and theoretical probability? And we could subtract them to figure out
And that's how you would figure out the difference.
That's right.
Subtract.
That's a fun little website. I'll put that in. We'll put it in your class so that you can practice too. All right, so let's do this next one. I think it's the last one. Speaking of differences,
The difference in how fast this computer loads compared to,
oh my gosh.
we might not get to that last question.
Well, I did kind of summarize it that we
you
do subtract.
Yes.
Right.
So I think since this won't load for us, they're probably good to go. Because I bet you at the end of this, it probably says, if you're confused, feel free to watch the next video.
But if you feel like you got it, you could just do the activity.
Go ahead and just get started with that activity.
It's
and
still
we
not
won't-
loaded.
It will not load.
All right.
Bye.
We love ya.